Welcome to On Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 109. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting middle you have benzene which is fused with 4-member system. Then you have side chain, both are anti. One side methyl, another side you have butene. The butene is a symmetrical one. You are heating it up. They ask you to find the product. The products are like 6-member ring. New 6-member ring is formed. Actually the 4-member ring is open and the position of the methyl group, both are syn or both are anti or what relatively different there. So from the reactant to product you might guess ring opening definitely occur and stereochemistry is important here. The answer is B. Let us see how. Here the starting middle you have benzene which attached with 4-member strain system. The strain is so high you are using the heat there. So you are using the heat and you have strain system. So definitely there will be a ring opening which is pericyclic reaction. So if you have ring opening with pericyclic reaction, 4 and pi electron mean you have Carn rotation there. So the Carn rotation occur, you have the ring opening. The ring is open. As per the simple concept, reaction should be over here. But the reaction not stopped at first step. Reaction further proceeds. How? Because there is the possibility of aromaticity there. So what really happens is the 2,3 bond rotates. So 2,3 bond rotate, it comes like benzene there, 6-member ring. So what really happens is again the thermal reaction happen. This time it's a disrotation because 6 pi electron is there. So disrotation is occurred there. The product is clearly B there. So ring is closed, you have the product B which is 2 methyl are anti to each other. Here you have to learn 2 important things. One is you should know which rotation occurs here, whether Carn rotation or disrotation. In thermal condition 4 and pi electron mean there is a Carn rotation. If it is 4 and plus 2 electron mean it is a disrotation there. Then second thing is about continuity of the reaction. The reaction not here stopped at first step because there is a possibility of aromaticity. So the system always supposed to do the stability. Here it is aromaticity. Then the question number 2. The starting middle is benzene attached with many functional groups directly with OH and with the methylene side chain you have amine and acid. You are using methanol and sulfuric acid. Next step you are using CBZ chloride which is the chlorobenzyl format and you have the sodium bicarbonate. They ask you to find the product. The products are mostly where the CBZ attacks there. CBZ attacks amine or acid or the alcohol or the ring or the new bond creation between nitrogen and methyl. Here the question is about CBZ where it will attach. So it is a protecting group. Which group it will be protected? The answer is A. Let us see how. The starting middle you have acid and amine. You are using methanol there. Methanol forms the ester with acid. Because the acid cannot react with amine, because it forms salt with amine, it is reversible. Again the acid cannot react with OH because it cannot be removed as water. Because OH attached with a double bonded carbon, so removing of COH is not easy. So the only possibility is COH, that's why the esterification. Second step you are having CBZ attack. Where it will be attacked there? You have CBZ as benzyl chloroformate. It is the nucleophilic center there. So amine attack the nucleophilic carbon there. It has chlorine leaving group. So only possibility is amine there. So it attacks because of its selectivity. So the product is clearly A there. The CBZ attached with amine. Here you have to learn 2 important things. The choice of the reagents there. In the first step, the sulfuric acid attack the acid, not the OH or NH2. Second step CBZ. CBZ only selective to the amine there. Aromatic OH is not a good nucleophile because of its resonance. Then the question number 3. The starting middle you have cyclic system 6-member ring. You have epoxide and another side tertiary butyl group. You are using azide. They ask you to find the product. The product is where the acid will attack. The acid will attack the third position or fourth position and the acid and alcohol will be syn or anti to each other. If you look at the reactant and product, you might guess the question is really about ring opening and its selectivity. The answer is D. Let us see how. The starting metal you are having epoxide, you are attacking with acid there. Here acid can attack any position 1 or 2, but acid will attack only 1. It is also from backside. Why? Because the one position is only axial free. Epoxide is formed between axial and equatorial. Here the axial bond should be on top. The equatorial is connected with. So only the axial position is free there. And the attack can be above or below. It's a SN2 kind of mechanism. So attack is from backside. So the product is really about 3SO formation and the ring is open with O-. Then you are attacking with acid. Then what really happened is the acid form OH there. So if you redraw nicely, you have the product D, which is OH above, acid below. Attack is from below, that's why acid below. Here you have to learn two important things. One is the attack is like SN2 attack, always on backside. So the product is always anti. Second thing is the attack need axial position. Only one have axial free, 3 is equatorial free. Attack is happen on 1, not on 2. Then the question number 4. The starting metal you have benzene attached with methoxide and you have side chain with syn-methyl and OTS. You are using potassium acetate and acetic acid. So you are having salt and acid. They ask you to find the product. The product is mostly OAC substitution. They are asking OAC is formed syn-fashion with methyl or trans-fashion with methyl or both methyl is syn or trans, as well as product is optically active or racemic. So the question is really about what is the intermediate is forming, how it dictates the specificity of product formation. So from the reactant to product, you might guess the question is all about intermediate formation and the product specificity, how the intermediate dictates the product. The answer is B. Let us see how. The starting metal you are having benzene, you have OTS. OTS is the good leaving group, but it has the assistance from phenyl group. The phenyl is electron rich, so it can involve the anchimeric assistance. It is called neighboring group participation. Simply, it helps the leaving group to leave quickly. So what really happens is the planar 3-member ring is formed there with benzene. So temporary formation, it's a kind of intermediate formation, then the attack of ACO. ACO can attack from any side A or B. Both leads to the different product which are the racemic mixture. So methyl is on syn to each other and the product is racemic mixture. The answer is clearly B there. Here you have to learn two important things. One is phenyl group can involve in the neighboring group participation. Second thing is the planar intermediate always leads to the racemic mixture. Here intermediate is planar, so you have attack from both sides possible. So product is always a racemic mixture. Then the question number 5. The starting metal you have two aldehyde, benzaldehyde and the paramethyl benzaldehyde. You are using titanium tetrachloride and lithium aluminum hydride. So you have metal and the lithium aluminum hydride reducing agent. They ask you to find the product. The products are mostly coupled one, either directly coupled from aldehyde or directly coupled from methyl substitute aldehyde or the combination of both. The final choice is all are possible. So from the titanium chloride and lithium aluminum hydride and carbonyl group, you might guess it's an important naming reaction. It's a coupling reaction and its possibilities. The answer is D. All are possible. Let us see how. This reaction is technically called as McMurray coupling. It creates the CC bond from two carbonyl group coupling. It is the reductive coupling. So the oxygen eliminated and new CC bond is formed there. Since both reactions having aldehyde, the both can be combined individually as well as the mixed way. The first thing is combination of benzaldehyde, you have stilbene. Second thing is methyl bond, so you have methyl stilbene. Third thing is you have benzaldehyde and methyl benzaldehyde. So what really happens is you have the combination direct CC bond. So you have the possibility of all reactions. So the product is all of those one. Here you have to learn two important things. One is McMurray coupling. It is a functional group conversion reaction. It converts CO into C double bond C. The aldehyde converted into alkene. Here, second thing is reaction can be cis or trans because there is no specificity. Both can be cis or trans. That's why trans bond is not specified here. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.